think that collaboration, communication, resilience is really important in scientific work, especially thinking about resilience, because there is a lot of frustration in science. But I think that if you are thinking about pioneering some new ideas, it doesn't come very easily. So it's something that you have to always see on the end of the road, which is that you are bringing something new to the world. But maybe when I'm thinking about unexpected skills which can help you during research, I would say as a neurobiologist that it's really important to expose your brain to different stimuli. So it doesn't only have to be reading papers or troubleshooting of your experiments. It can be, I don't know, simple walk in the forest or some other creative activities. I think that science is really very, very creative work, even though people think that it's only about some formulas or something, protocols, and it's boring. But I think the real base for science is creativity. So anything what brings creativity in your life, it's helping you even to survive that frustrations which I mentioned. So for me, for example, it is music. So I would say that, for example, music can be very helpful in scientific work, because it's also stimulating your brain with different stimuli, and also bringing some other skills, which can be just thinking about, I don't know, composing the music and what can be the next chord. And this is also something what I am using not only to relax, which is also important, but also to stimulate the brain to new ideas. So I would say, for example, music, but it can be anything creative or even related to physical activity, meaning running or hiking. So I would recommend everybody not to only look at the science as something what needs better communication, better resilience, but I think it also needs better creativity. And I would also support my students to proceed creative thinking, and it can be anything. I'm thinking about unexpected twists. It's always related to my career, because after finishing my PhD, I really wanted to proceed my career as a neurobiologist. But I finished my PhD in evolution of mitochondrial genomes in yeast, which is very far away from neurobiology and from neurons and from Parkinson's disease. But I really desired to work in this field, and it was something what fascinated me more than yeast, even though they are very useful model organisms. And I'm grateful that I got the background in this. So after quite desperate period of looking for a postdoc in neuroscience, I found position in CRISPR-Cas9 targeting of genome, which was something like step in between where I was and where I really wanted to be. I found out that I need some kind of set of skills which I didn't have at the time to help me to proceed in my career the direction which I want to go. So that's why in this time I started to work with CRISPR-Cas9, even though it wasn't directly related to neurobiology. And this is maybe something what I learned, and what was unexpected twist, that if you cannot do the step forward, sometimes it's better to do the step sidewise, just to not to get stuck at one spot. So again, expose yourself to different skills. After my CRISPR-Cas9 experience, I started to look for another postdoc And after this, I got a position at Mayo Clinic in the US, in Florida, which was like dream came true. And I started to work in Parkinson's disease. And what they were looking for in the advertise was for this job was that they are looking for somebody who has experience in mitochondria, which I got in my PhD, even though it was in yeast, and also with CRISPR-Cas9 targeting, because they were interested in mutations related to Parkinson's disease. So even though I didn't know that I'm building the set of skills which are helping me in the future, actually I was, and it was very fortunate that suddenly all these things came together and helped me to make my dream come true. And I think this is also a kind of example that if you cannot proceed with something straight, it doesn't mean that some side way tours will not help you in the future. And I would encourage everybody to again increase the set of skills which you have. It can be anything. It can be programming. It can be some other microscopy technique. So don't always look only on the topic. Exposing your brain and your skills, different experiences from different fields, will just make you more whole scientist, and it will help you in the future to do the things which you want to do.
I think that one of the most important skills is communication, because how we communicate matters. And of course, this can mean a lot of things, because when we start our work, we usually discuss our work with our colleagues, with our supervisor, or even later with our students about their own work. And it's not just about talking and about your experience and opinion or sharing your knowledge. It's usually also about listening to them, listening to others, understanding their feelings, asking for advice, and being able to accept a different opinion, because everyone has a different opinion. And all these relationships that we create by communicating with others are important, because they can have a huge impact on our work and maybe also to our future. And from discussing something, like something basic that is bothering us, we get to solving the problem. And maybe we can also get new collaborations or even a job opportunity. As a young researcher, we usually get in touch with communicating in science, which means presenting our work at scientific events or sharing our knowledge with general public. And many scientists, believe it or not, including me, they have problems with public speaking. When I started working in the promotion of science back in 2018, I was terrified. I was scared to stand in front of the camera. But all these big skills can be acquired, and stepping out of my comfort zone and doing things that at that time felt very uncomfortable were actually a great way of learning these communication skills. And that's why I'm here today, to share this experience with others. So in my opinion, for a young scientist, it is very good to learn how to communicate with others. No matter how old we are or in which scientific position we are, we need communication. And communication is the basis for a good science. When I look back at my career and at my research work, I would say that science does not always work the way we want. And nature usually has its own rules, and our job is not to manipulate with them, but to understand them. And I can say for myself that my own research work is a huge collection of unsuccessful experiments. Huge. But this is not a reason to give up, because eventually, if you believe in your work and you're resilient enough and ask for advice and connect with the right people and never give up, and you're willing to learn new things and to try new things, you will slowly figure it out. And at the end, the learning process, so how you get there, how you get to your findings, is usually more important than the findings themselves. For me, being a scientist means to be curious, to ask questions, to critically evaluate the information you get, because we don't always get truthful information. And at the same time, still being open to the ideas of others, and even if we don't really agree with them. Then it also means to be willing to learn new things every day and to not be afraid of trying new things. And of course, to be willing to help others, because we can help them grow as others helped us grow. And to conclude, I would say that without communication and without teamwork, we could not be able to do great science.
If I have to think of useful and technical skills in my work, I will choose two: strategic planning first and problem solving. Because our work takes place primarily in nature, often in wood, so strategic planning becomes essential for us. A large part of our role involves studying the seasonal cycle first in order to highlight the unique characteristics of the natural environment around us at the specific times of the year. This allows us to create high-quality activities. However, nature can be unpredictable sometimes. Weather conditions or environmental changes can affect our plans at any moment. That's why problem solving is just as crucial to me. Sudden rain or strong winds or unexpected changes in the landscape can require us to adapt our activities quickly, rethinking format, location, timing, and these challenges call for flexibility, creativity, and quick decision-making. So the combination of these two skills, strategic planning and problem solving, allows us to deliver meaningful and interesting educational experiences, and also they enable us to balance preparation with spontaneity, science with creativity, and structure with ever-changing rhythm of the natural world. Based on my experience, one piece of advice I will give to anyone approaching the world of science is seek out as many different experiences as possible, even those they may seem unrelated at first. Cultivate your personal interests, explore new fields, and allow yourself to be influenced, contaminated, in the best sense, by other people's perspectives, disciplines, and passions. Science thrives on new perspectives and is grounded in continuous inquiry. It's not a collection of fixed truths, but an evolving process. Rather, it's about continuously questioning what might seem certain and creating space for unexpected connections between different forms of knowledge. The image of science that I have come to embrace is dynamic, a space where disciplines meet and where new questions emerge from the dialogue between diverse ways of seeing the world. Therefore, my advice is stay curious. By staying curious, exploring diverse experiences, and embracing different ways of thinking, you open yourself to unexpected connection and new questions. So remaining curious is important for fostering cross-pollination, both in your own life and consequently in your work, and in the quality and in the complexity that you bring to your activities.
Yeah, so at the beginning, you make a lot of mistakes, and that's normal. You need to learn during your career how to cope with frustration, and you need to learn that what matters is not perfection, is resilience and is persistence. And that instead of trying to be a perfectionist, you need to try to be meticulous in your work. And also another really good skill is to be rigorous. That's also that you also learn during your career. You need to learn how to have a critical mindset and to distinguish what's really innovative and relevant from where it's not. And that's something you learn during your path. Is something that at the beginning is impossible to know. You really need to make mistakes to get to that point. Usually, historically, female animals and women have been excluded from experimental designs and from population studies, and that's very, very important. That can be related to the fact that women report more adverse effects to drugs than men. Could be very related, and that's why we need more diverse perspectives to be more accurate to reality and to increase the benefit that science can report to society. And for example, my PhD supervisor has designed a lot of studies on diets that can be beneficial for neurodegeneration. And they designed these studies both in female and male mice. And we found out that there are very, very different results depending on the sex of the animal. And this, of course, would be hidden if you don't work with female and male animals. So that's why it's truly important. And this also can be applied in population studies with ethnic minorities, not only female and male individuals. It's important to know that to believe in yourself and to know that you belong to science, and that no matter what other people say, your voice deserves to be heard. And that the research it's based on curiosity and on discovery. So if you really like this, go for it. And based on my experience, what is very, very important is to find a mentor that can guide you through this process.